All right, for part 3 of this tutorial, we will now use the MGS web simulator to test and evaluate our updated Microchip Graphics Suite application. The other method for testing and debugging and developing is to use the simulator. So let's go back to the developer help page. Help. Let's navigate to Learn Software Tools, Software Framework, Microchip Graphics Suite. Let's go to the Microchip Graphics Suite Harmony User Guide. So on this page, you'll find a lot more information about how to get started, how to use the composer, how you would design your application with graphics, how you would have the rest of the system interact with the graphics library. But if you navigate to the Harmony Simulator section, this provides the instructions on how you could download and install the simulator. So it's just an installer that you download from GitHub. So go to this page right here, go to GitHub. You just download this executable, and that will automatically install the simulator and fetch the necessary tool chain for you to run the simulator. All right, so I have the tool already installed in my computer. So I could just go simulator, like that. So this is how it looks like, right? So to begin using the simulator, I need to first convert my Harmony project so that instead of using an embedded display controller, you actually talk to a simulator. So I can just right click here, disconnect between the Legato and the display controller. I right click on Legato, this node right here that's currently red, go to satisfiers, and then select MGS simulator. That will pull in the simulator. If you're using a timer service in your application, the MGS simulator also provides a way to simulate a basic timer. So you can disconnect your time system service if you're using it for your timer functions. Disconnect this guy and then just connect it there. All right. So going back to the so we need to configure MGS simulator to match the resolution and color mode that we have designed with Composer. Right. So MGS simulator, go to graphics display subsystem. Here we can select the resolution. So this resolution is for Composer. You can go to project settings. Display, it's 720 by 1280. So we just use the same size here. There are default display types and sizes. If you can't find the size you are targeting, just go to custom, and we go 720 by 1280. Right. This is a portrait mode display that we're targeting. Yes, we are using RGB565, and we can confirm that here in Composer. Go to project settings, render, it's RGB565. You can also check here the layers are RGB565 for both screens. So that should match what we have. We're using only one layer. So there's only one layer in each of the screen. Right? And you should also match the settings that we have with the actual display controller that we're using for the embedded target. So only the base layer is enabled, so just one layer. In most cases, you don't have to configure the rest of the settings for the MGS simulator. If you need more memory because you're using larger buffers, then you may need to increase these memory settings here. And for the most part, this should work. All right, so now we will generate for the simulator. So now that I have that configured there, I'll click generate. When it's done generating, now I will find this file right here. So going back to the project folder, firmware, I go to source, so this path, go to quick start, firmware, go to source. For the various configurations, so for the target display that we're using, this guy, now you will find this MGS WS file, which is the simulator project file. So we will use the simulator, launch it, click open, and navigate to the directory right here. Let's copy this. There. Now we can open that. All right. So after opening the simulator project file, it shows you the details. Just make sure that, okay, it matches what I've set here in terms of the resolution, the color mode, the number of layers. If the quick start example has a couple of application source files, which has the button callbacks that provide the callback functions when the buttons are pressed. So we add those to the build. Just click build. So there are two modes here. There's the web mode, which generates an HTML output, and then there's a native mode, which will generate a Visual Studio project that you can now use to develop and debug the project with natively on the desktop. Okay, so now that we added the application source files, now we could just click build, and that will build the project, convert it to WebAssembly, and then generate an HTML file. You can click the HTML file, and we'll launch the now updated quick start design on a browser. So as you can see, it now has the hello world change there. If you click quick start, then it goes to the second screen, which is what we have designed, what is designed for the quick start application. This help screen right here. And you can toggle back and forth. Once you're done using the simulator and you want to convert back to the embedded target, you could just go to the project graph, right click on the nodes here and disconnect them, right? And then connect the time system service back to the timer peripheral and connect the legato display back to the LED display driver. If there is a GPU that is available on the platform, you could also connect this back to the GPU for legato to use the GPU on the embedded target. Once it's done, you click go back to Resource Management tab, click Generate, and now this will regenerate the project for the embedded target. So that concludes our tutorial. We have just demonstrated how you can use the Quick Start project for the target microprocessor, which is the SAMA7D65, and the 5-inch MIPI 720p display, how you could use that to start developing and creating graphics applications using MGS Harmony.